a real quick little thing. Many of you, I know, are going to go on to take chemistry in college. Some of you are going to take a lot of chemistry in college. Here's my hedging my bets and covering my butt. We've learned how to name molecular compounds using prefixes. So SO2 is sulfur dioxide. There is another system for doing this. It's called stock system. It relies on those same Roman numerals that we use with transition metal compounds. And what you are doing is finding the oxidation number on the first element, and you're naming the compound for that. So instead of sulfur dioxide, we call it sulfur 4 oxide because, well, SO2, oxidation number here, -2, times 2 minus 4. Here that has to be +4 divided by 1, +4. So we call that compound sulfur 4 oxide. This one would be sulfur 3 oxide for the same reason. Now, that said, 2 years of college chemistry. I never heard a single person refer to a compound using this style of nomenclature. Never. Now, the guy I had for general chemistry, Dr. Friedrich Kochnat, his PhD was from the 60s. Okay? So he had been in chemistry for a long time, doing chemistry for a long time. I don't know if had I had someone who was younger, if they would have been using this system. But the guy I had for organic chemistry, who the ink on his PhD was barely dry at the time that I had him, he didn't use this either. Now, we had organic, so we didn't talk about as many inorganic compounds. So I want you to be aware that this exists. If you get to college, the favor that I have for you, those of you who are going to take college chemistry, if you get to college chemistry and they are using exclusively the stock system, please, for the love of Pete, send me an email. Say, Moser, I was badly prepared when they refer to molecular compounds in general chemistry. They use stock nomenclature, and you told me it existed, but we never ever practiced it. Okay? Because we're not going to practice it. Just being honest. But if you find that this is commonly being used when you go to college chemistry, let me know, and I'll change what I'm doing. My experience was that this didn't get used, and of course my college chemistry experience is now more and more dated. So it exists. It's a different way of naming molecular compounds. Now you know about it. Now, how do we use chemical formulas? The biggest thing we use chemical formulas for is the math associated with chemical reactions. So chapter 9 is stoichiometry. Before we get to that, we have to go through writing and balancing equations. We have to go through all of that. But to do anything further mathematical with chemical compounds, you have to be able to add up the molar mass of a chemical compound. So let's take our old friend H2O. So this is molar mass. And this is actually slide 16 that says chemical formulas, but I do not have it. So when we find molar mass, that's the mass of 1 mole of a substance. We can have a mole of water, and we write down the molar mass of each element and how many there are. Gesundheit. 18.02, and this is grams per mole would be your units for molar mass. Grams per mole. You've already done this with individual elements. You've found molar mass of carbon, of iron, of sodium. You've found how many moles of oxygen are there in 500 grams of oxygen. Now we're just expanding that to compounds. That's all this is. So there are two words, and this is actually slide 19. It's titled Molecular Mass versus Formula Mass. So, and these actually, I guess, these are both in AMUs. I jumped ahead to molar mass, sorry. So molecular mass is the average mass of what? Grant's tomb. A molecule. So, you know, average mass of one molecule. Could we use molecular mass for sodium chloride? Could we find the molecular mass of sodium chloride? No. Why? Because there are no molecules. So when we're talking about ionic compounds, we talk about formula mass, and it's the average mass of formula unit. Okay, so it's just the average mass of a formula unit. So we can do this for sodium chloride, we can do this for magnesium bromide, we can do this for ionic compounds, because we're not talking about a molecule. So if we want to find the formula mass of sodium nitrate, common ionic compound. You know, in the notes, I walk you through doing the whole process of doing a factor label for each of these, and the way that looks is like this. One atom of sodium has a mass of 22.99. Hold on. AMUs. Well, actually, we have one atom of sodium. It has a mass of 22.99 AMUs in every one atom of sodium. So this is 22.99 AMUs. We go through the same process for each of the elements in the compound. I'll shrink that. So we have one nitrogen. One nitrogen atom has a mass of 14.01 AMUs. 14.01 AMUs. And, you know, you might do this for one of them, and then you don't need to do this anymore. You see it conceptually. We have 3 oxygen atoms, and every one oxygen atom has a mass of 16.00 AMUs. So there we have a total mass of 48.00 AMUs. And we're just adding those 3 numbers. So we get the mass for one formula unit of sodium nitrate is 85 AMUs. This is pretty easy. As you get really quick at these, my tendency is to do this. I list everything. Oops. And I just make a little note for myself. You do not have to do the factor labels for these once you understand that conceptually. So now, how is this related? And I sort of jumped ahead to molar mass. And this is cued off of slide 21. So molar mass is the mass of 1 mole. It's the exact same calculation as formula mass. The only difference is the units. So let's take our sodium nitrate. So for sodium nitrate, formula mass equals 85.00 AMUs, atomic mass units. The molar mass is equal to 85 grams per mole. Same calculation. And same thing as you've done with finding molar mass of other substances. So very simple, very easy. The tricky ones, I'll do one tricky one with you, are things like this. What's that called? Magnesium nitrate. Yeah. So for magnesium nitrate, where is the tiger trap on this one? What's the thing you can fall prey to? Not correctly counting the number of atoms you've got, represented by those nitrate ions. So the thing to, so you've got magnesium, which has got a molar mass of 24.31 times 1. We have nitrogen. How many? It's 14.01. How many nitrogens do we have? 2. Because remember, and I'm going to do the sort of quick and dirty on this, you have 2 of these entire nitrate ions hanging out with 1 magnesium ion. And if you have to do that's sort of what we would call a structural formula. It's not a Lewis diagram because I didn't put in all the unshared electrons. If you need to do that for yourself, do it. But that allows you to say, oh yeah, I've got 2 nitrogens. How many oxygens do I have? 6. And that's because you have to multiply those numbers together. That's the most common trap to fall into with these. Oops. So who's got a raw number for the molar mass of magnesium nitrate? 148.33. And what would be the units if this is molar mass? Grams per mole. Grams per mole. Okay? So that gets you through the molar mass stuff. Tomorrow we'll start with some basic compositional stoichiometry for compounds, or Wednesday if we have a snow day.